Hello and welcome back. In this video, we'll finish off our example of file processing, including writing to a file and producing some graphical output. So if you remember, we're processing this data file from NIWA that contains sunshine measures in this section of data here for particular days and dates, and that's the data we care about. But the file contains an awful lot of additional data, including all of this preamble stuff and closing stuff. And we were using, our previous algorithm used this space in the file at line 7, then skipped a couple of lines in order to access the lines that we care about, and it stopped at the next space. So here's a different algorithm for doing the same data extraction. First off, we'll make a list of all of the lines in the file. Then we'll make a sublist using our accumulator pattern to gather up only those lines after line 3 that begin with a particular station name, in this case Christchurch Aero. Okay, there's Christchurch Aero. So we only care about the lines that begin with Christchurch Aero, but we don't care about line 3 that's in the preamble identifying the name of the station. Okay, so for each of those lines that begins with Christchurch Aero, we'll split the line. We'll do what we did before in the last example. Split the line into pieces separated by commas. The date is the piece at index 1. We need to get the month and the day from the date because we don't care about the year component that begins that piece. We'll then extract the sunshine measure from the piece at index 3, and we'll process the month, day, and sunshine. So that's a different algorithm. Rather than relying on beginning with a blank line and ending with a blank line, we'll just extract those lines that begin with the particular station name. So maybe this is a simpler algorithm, but it only works for one particular base station. It only works for Christchurch Aero. And it'll also fail for if our data file is huge. In this case, it's a small file. But if the data file is huge, well, we can't read all of those lines into memory in one go. So general algorithms are generally better than specific algorithms. So we can improve that algorithm in terms of its code reusability by extracting the station name from line 3. So, let's say that line 3 identified a Hokitika station. Then we would expect all of these different lines here to begin with Hokitika. So a better algorithm would be a better algorithm that's still a version of the last one would be to get a list of all of the files in all of the lines in the file, extract the station name by starting at line 3 and extracting stuff up until the initial comma. Okay, so that would give us our station name. Then we make a list of all of those lines after line 3 that begin with the station name. So now this should work with any different base station, regardless of where it is. Hokitika, Christchurch Aero, New Plymouth, wherever. Okay, the rest of the algorithm is pretty similar. So we're just thinking of different ways to solve the same problem and assessing their pros and cons. The code to do that version looks something like this. We open up our file, we read all of the lines at once using infile.readLines, okay, the readLines method provided by our file object. We then close the file because we've now got all of that data into memory and we might as well close off the file, we don't need it anymore. Our station name is the lines indexed by 2, that's line index 0, line index 1, line index 2, okay, and then it's the split of that, spacing the split on commas at index 0, okay, meaning the first chunk on line index 2. So that'll give us the station name. And then we use our accumulator pattern to say, starting with the data being empty, for each of the lines from line 3 to the end of the file, if the line starts with the station name, accumulate that data. So we're using the append method to add on to our list. And finally, processing the data looks exactly like it did in our previous algorithm. So which of those algorithms, algorithm 1 or algorithm 2b, is best? Well, there are many other algorithms that you could be thinking of, and actually neither of the algorithms that we've looked is actually much good at all. They're both really pretty bad. They both fail if the file format is changed in some way. So we've inferred the format of this file based on just a single example. We've looked at this example and we've said, I'm guessing all files are always going to be of the same format, and that's really risky. What would be better is if we had a specification of the file format from NIWA, and that way we could be confident that our generalized method of extracting the station name and extracting lines that actually begin with the station name will succeed. At the moment, we've just guessed it'll work. If NIWA told us, yes, all files will adhere to that structure, we'd be much more confident that our program will work in general. Okay, so far when we've run our programs, and let's just run it once more. Here's a tiny example. Actually, let's do this version and run it. Okay, we see that it's producing some output by printing it to the standard output. So we've just displayed the textual output with print. But we could write a new file, so instead of having this dump out here, we could put it to a file. Maybe in a CSV, comma-separated values format, or using HTML so that we can make it accessible to others on the web. Or we could produce graphical output. So that's where we're going next, other formats of outputting the results. So writing output to files, it's really a simple process. All we need to do is open up the name of the file that we want. So if we're wanting to produce a new file that say is called myoutput.txt, well, you just open up the name of the output file, passing it in as a string to the open function. And in this case, we're wanting to open it for writing, so we pass in a string that contains just the character W. And that gives us a reference to a new file, and that new file will initially be empty, and we can write data to that file. So our data is going to take the format of having a month and a day, and then to 3 decimal points of accuracy, it'll contain the sunshine measure. And there's a new line character at the end of this data. Okay? So that's how we'd format up our data, ready to be written out. So anytime we want to write our data to a file, we just say outFile, which is our reference to the file, .write, the write method defined for any file object, and we can pass in the data that we're wanting to write. Okay, so when using the write method, we must explicitly include that new line character if we want it to occur. So it's not like print, where we get the new line character as a result of calling the function, unless we suppress it by using the end argument to say we want a different character at the end. Okay, so if we want a new line at the end of the data that we write, we've got to explicitly add it, and that's what we're doing here when we're formatting the data to be output. Once we're done with writing data to the file, it's always good manners to release our resources and explicitly close that file. So it's important that at some point we have outfile.close. We've opened the file here for writing. At some point we should close it too. So you should have a go maybe at adapting one of these files, one of these programs that has been printing the output, and instead writing the output to a file. That would be a good exercise for you to do now. The final thing that's really outside our official curriculum, except for graphical user interfaces, which we'll get to right at the very end of the course, sometimes scientists in particular, and engineers and so on, should be aware of how they can go about producing graphical output, because if you're processing scientific data, you're very likely to want to produce plots. So there's a wonderful package produced by others called matplotlib that provides terrific support for producing nice graphical plots. It's multi-platform, it's free, it's extremely flexible, and it's installed on all of our lab machines. And you can easily install it on your machine at home. Just do a lookup for matplotlib using Google search. Okay, so the details of this program you don't really need to understand, but if you're curious, go off and examine this code in detail and check that you understand how it's working. On this page, everything should be pretty much comprehensible, except for maybe the import, which we'll get to a little bit later in the course, at the start of next term. So this page, everything should be more or less comprehensible to you. You should be able to follow it. On the next page, this method or function plot sunshines This is a bit more tricky because it's using all of the capabilities defined by matplotlib. So this will be a bit more tricky for you to understand. But in general, I'll just show you the outcome of doing this. What I've got is a new data file called sunshine.txt2. So this is a much bigger file. It's got every day's sunshine readings for an entire year, and that's 2017. And if I run my example to process it, so it's just the example that you're seeing here, there's the plot sunshines method. I'll run it, it'll process for a few seconds, it's evaluating it, and I've just had a window pop up on my other screen, and there it is. That's what it's done. It's plotted out from Jan 1st to the end of the year, the amount of sunshine per day. So you can see that on average, I guess, there's a general trend that sunshine hours are reducing as you'd expect in winter and increasing in the summer. So study that in detail if you like. It's not part of the curriculum, but it could be very useful for you in future courses. Okay, that's it for this video, and that's it for this term. So I hope you've had a good start in programming with Python, and good luck in the second term. Thanks.